The failure modes, effects and criticality analysis procedure is a tool that can contribute to improved designs for products and processes, resulting in higher reliability, better quality, increased safety, enhanced customer satisfaction and reduced costs. The goal of performing a Fmea is to review all of the functions or components of your system in order to determine ways in which a failure can occur, and to define the resulting effects of the failures on your system. Once this is completed, a Fmea can be used to determine the most critical failure modes, and then determine how these critical failures can be minimized or eliminated. A Fmea can be performed at a number of different levels of detail, but regardless of the level of detail being reviewed, the purpose is the same. The process of Fmea should start with the process flow. Each of the operation in the process should be mapped and the product characteristic identified. This is otherwise called as function in Fmea. For example, in the operation of call center, the time to respond is a characteristic and hence a function. Each of this failure mode is now derived by studying the ways of failure, but with several operation it is likely to see hundreds of failure modes that are possible. This, when multiplied by the number of causes, would exponentially grow the possibilities of fixes. In order to get more focus, Fmea uses a risk ranking process, which is a numerical conversion of the impact, the frequency of occurring and the current set of controls.
Consider an example of an airline industry where an airline price filing system has the following issues. The process involves evaluation of the new price and uploading into the system for distributing the fares to all. What is expected of this task is to ensure the fares are filed for the correct market at the correct currency. Filing in the wrong currency is possible, and this leads to tickets sold at very check levels and resulting in huge loss. The check tool that exists now is missed sometime, especially when the speed to market is very demanding. Potential failure mode is defined as the manner in which the process could potentially fail to meet the process requirements. A few assumptions shall be made when Fmea is done. For example, exceptions can be made by the Fmea team where historical data indicate deficiencies in incoming part quality. The team should also assume that the basic design of the product is correct. However, if there are design issues which result in process concerns, those issues should be communicated to the design team for resolution. If the requirements have been well defined, then the potential failure mode is readily identifiable by determining the condition when a specific requirement is not met. Each requirement may have multiple failure modes. A large number of failure modes identified for a single requirement usually indicates that the requirement is not well defined. The assumption is made that the failure could occur but may not necessarily occur. Consequently, the use of the word potential. Verification of completeness of the potential failure modes can be made through a review of past things gone wrong, concerns, reject or scrap reports, and group brainstorming. Potential effects of failure are defined as the effects of the failure mode as perceived by the customer. The effects of the failure should be described in terms of what the customer might notice or experience, remembering that the customer may be an internal customer as well as the ultimate end user. The customer in this context could be the next operation, subsequent operations or locations, the dealer, and/or the vehicle owner. In an inventory control case, the effect is that the production is delayed, but this happened because there was no raw material in the stock. The question to ask in this situation is, what is the cause of this failure mode and not the effect? Why was the reorder point not done correctly? Is it a calculation issue, or is it an understanding issue, or are there not enough data to support this service? Once this is done, the next question is, do we have control now? Yes, there is. We use an inventory control system, but despite this the reorder was not done correctly. Is there a better method? All these are part of the Fmea analysis. How does an improper installation affect the moisture content inside the compressor, and how this could have been improved by following a set of rules or procedure? The tool can also be used to establish and optimize maintenance plans for repairable systems and/or contribute to control plans and other quality assurance procedures. It provides a knowledge base of failure mode and corrective action information that can be used as a resource in future troubleshooting efforts and as a training tool for new engineers. RPN, or risk priority number, is a measure of risk and is derived by combining the impact of effect, the frequency of occurrence and the ability to detect. It is a product of all these rating scales. Sorting the failure mode and the cause using this RPN scale is important for focusing the resources and satisfying the customer. When potential failure mode is generated, the list of failure modes must be continuously updated. This results in a failure mode database which can be used for subsequent analysis. The failure modes should be updated when a new symptom of the problem manifests and should be dynamic to the latest symptom of the problem. The failure mode is the manner in which a component, subsystem or system failed to meet the purpose which it was intended to. Fmea occurrence and detection rankings should be evolved out of a long-term understanding of the issues and their revenue implications. The ranking given should be based on consensus. How to quantify the impact of a failure mode. Severity is the value associated with the most serious effect for a given failure mode. Severity is a relative ranking within the scope of the individual Fmea. The team should agree on evaluation criteria and a ranking system and apply them consistently, even if modified for individual process analysis. It is not recommended to modify criteria ranking values of 9 and 10. Failure modes with a rank of severity 1 should not be analyzed further. Occurrence, or the frequency of the cause, is the likelihood that a specific cause, mechanism will occur resulting in the failure mode within the design life. The likelihood of occurrence ranking number has a relative meaning rather than an absolute value. A consistent occurrence ranking system should be used to ensure continuity. Estimate the likelihood of occurrence of a potential cause of failure on a 1 to 10 scale. A typical failure modes and effects analysis incorporates some method to evaluate the risk associated with the potential problems identified through the analysis. The two most common methods, risk priority numbers and criticality analysis. To use qualitative criticality analysis to evaluate risk and prioritize corrective actions, the analysis team must first rate the severity of the potential effects of failure and rate the likelihood of occurrence for each potential failure mode. It is then possible to compare failure modes via a criticality matrix, which identifies severity on the horizontal axis and occurrence on the vertical axis. Detection is the rank associated with the best detection control listed in the detection controls column. Detection is a relative ranking within the scope of the individual Fmea. In order to achieve a lower ranking, generally the planned detection control has to be improved. A number from 1 to 10, depending on how unlikely it is that the fault will be detected by the system responsible design control process, quality testing, etc.